Um, So, my plan for this class is that I don't want to be lecturing every day, because I think that would not be a good way for all of us to spend this class time together. But I did want to start off this class with kind of explaining what I'm hoping to do in this course right now. So I gave you a design problem. This week it's not a building design problem. Again, it's just kind of one of those, you could probably do it online. Wasn't exactly sure whether or not we were going to be meeting in person this week. Or if we were going to get snowed out, which that was also a possibility. But the design problem that you have for this week is basically doing a little bit of research. Now, when I give you a design problem, there is not one correct answer. There is usually a correct methodology. If you can follow the correct methodology, you'll be fine on your design problems. If you can't, then yeah, you're gonna struggle. But this one's pretty straightforward. I just want you to make a table. Okay? And the idea behind the table is come up with let's see, what all characteristics did I put on the assignment?
One of them is a force. One's a CPU, and there's like an 8, 16, 32, 64.
Okay, so you said, I think the first one was cost, wasn't it? Yeah. So let's say first category is cost. Second category is your max clock speed. Now, for most of these chips, they don't give a minimum clock speed because you can run them pretty slow. Also, most people aren't trying to run them very slow, so that's a little bit of a different issue. Most people are just looking at what that max clock speed is because it defines maximum performance. Power consumption, and sometimes that is just as much as like it has to be able to take a 5-volt power supply. You may be able to get one that actually gives you a wattage for how much power it consumes, which that would be awesome. But if you only can get like 5-volt, 12-volt, that's as much as you can get. And then a description, and then last category that I want is there are 2 categories. One of them is a link to the component on Mouser. And one of them is a link to the data sheet. Okay, because they are 2 completely different things. Mouser is a distributor, which means what they do is they purchase components from vendors or manufacturing companies, and then they sell them to you. That's the whole purpose of it. It's a nice one-stop place. Mouser themselves, they don't put together data sheets. Certainly not for the hundreds of thousands of different parts that they sell. Most data sheets have been developed by companies or are available online. A lot of data sheets haven't changed in decades. They might have been updated to look nice, but I have an electronics book, ordering book from my uncle, and all of the components in that book are identical to the ones that are online. And it's from 1997. So that was kind of a shocker for me. But a lot of these technologies haven't changed a lot. If you need a resistor, it's a resistor. Now there are a lot of technologies that have changed and grown and adjusted. You have resistors that are small enough that they can be embedded into integrated chips themselves. And that's pretty common in anymore, which is one of the reasons why you see so many massive bunches of resistors, like on that treadmill kit that I showed you. Tons of resistors everywhere. Most of those were just power control that went to the integrated chips. Anymore, those resistors are actually built into the chips because it reduces the size of the microchip overall, and it reduces the complexity, also reduces the potential for failure, and you can get a lot of really good performance out of those. But having resistors embedded into the integrated chips, it streamlines the process. So, but a lot of these components haven't really changed dramatically. Now I'm hoping that the processors that you find are not the same processors from the 1980s. Those are a little different. I don't even know if they sell most of those anymore. Processor technology has really advanced. And this is one of the greatest areas of improvement in electronics. But my goal here is you're going to find some funky things when it comes to this in comparison with this. It used to be that if you could buy a processor for $100, you were doing pretty good. That was a good day. Today's world, you can buy a microprocessor. It might be an 8-bit, 16-bit, 32-bit, doesn't matter, for about $1. And that is ridiculous. We have reached that state of technology that now they don't have the greatest clocking speeds and they don't have the greatest power, but some of those processors can be as powerful as entire computers were 20 years ago. So and you can buy it for $8. You can buy a soda, or you can buy a 1990s era computer, because that's fantastic. There's a lot of things that you can still do with those types of processors. You can plug them into little simple systems. For your application in an IoT system, you're going to be looking for a cheap processor. Why? Because cheap processors tend to have pretty good performance, don't consume a lot of power because they kind of suck. And that's fine. You don't need a processor that's really super powerful for an IoT device. But I want you to spend a little bit of time looking at the processors. Familiarize yourself with datasheets. In digital componentry, this is something that I don't even know how to teach you, but datasheets are kind of a huge deal. If you're working with any kind of electronic components, you have to know how to read a datasheet. And even just parsing through there and knowing what most of it says is good enough. So spend some time looking at the datasheets, and that's what I want for your design problem. You should be able to finish, if not all of it, at least most of it in class today. Submit it online. Good to go for next week. We can talk about the IoT stuff too, if you would like. Any takers on that one?
The principles or what?
Yeah, the principles, the one that's due next week on Monday. Do you want to talk about it?
I don't think so. I have to look at what your assignment says.
Okay, I can throw that up on the board. Let me actually go ahead and hook up the HDMI cable. All right, let's go look at the assignment that I gave you, the IoT principles. I guess I should probably turn on the projector. That would make the most sense. There we go. Okay, there are three major questions that I want you to answer when it comes to IoT devices. And I feel like these three questions, while they don't quite encompass the entirety of what is IoT, I feel like it's a really good, if you can understand what the answers to these questions are, you have a pretty good understanding of what IoT is in general. So here you have, what is the difference between a regular device and an IoT device? There are differences. IoT devices have requirements and constraints on them that regular devices don't have. And we have talked a little bit about this in our coursework, because I've told you that IoT devices don't require a lot of power, that kind of a thing. There are other requirements other than just power, or the fact that they usually don't have a very intense, they usually don't have memory on board. That's rare for an IoT device, something like that. But you can talk about what the difference is between normal devices or normal electronic equipment, normal sensors, and IoT. When you talk about measures of quality, it is really important to understand what is it that makes a good IoT device. An IoT device itself, I mean, if there are no measures of quality, then we can just start slapping stuff together and be like, hey Austin, let's go grab a heat sensor and connect it to a cellular chip. That's it. That's all it takes. And really, I mean, you can do that. The primitive IoT devices, that's really all they did. We're far enough into the development of Internet of Things devices that in today's world we actually don't need to just simply slap things together and call it a good day. We can be deliberate in our design. But I also want you to spend some time looking at the book's description, chapter 1, all of you read that, and compare it. How does IoT compare to what the book describes as good design for electronic equipment? I don't want to see more than a page for your responses. So if you're trying to sit there and be like, oh man, 30 pages. Whew, got a weekend and my fingers are on fire. I just drank 15 Red Bulls. Don't do that, please. If you understand these three answers, you can fit it in a page. Okay. Any questions about what I'm looking for here?
So you mean like a page for each question, or just all three?
Just all three, one page. Yeah. If you did a page for each three questions, I mean, you'd show me that you know a lot about each, but you would end up saying a whole lot of stuff you probably don't even need to say. And I just feel like that's a waste of both of our times. If you understand it, that's the part that I care about most. And you can prove that in less than a third of a page. Okay, any other questions? All right. So I suggested for your assignment you actually have to use Mouser. Now, the reason why I say Mouser is because Mouser is one of the bigger suppliers of electronic components. They have just about everything. You can buy a whole lot of any kind of electronic products you ever need. You need resistors, diodes, you need integrated chips, you even need power supplies. Mouser has most of that equipment. The hobbyist who likes building little electronic devices in their spare time will probably be subscribed to Mouser, just because there's so many things that are available here. But for your case, if we just look up processor in the handy dandy search bar. Oh, come on, Mouser, don't fail me now. First of all, you have 83,000 components that pop up right away. And here are the subcategories of everything. There are 12,300 field programmable gate arrays. That's nice. What we're mostly looking for is what's on the left side there, the 8-bit, 16-bit, 32-bit. Microprocessors are down there. I'm not sure if these CPUs are also on this page. I guess we'll look real quick. Ah, yes. Right there. Good eye, Kenny. But yeah, all I want you to do is just jump into these areas. Here, I'm going to jump into one that isn't related to your assignment. If you want to add more than what I asked you for, that's great. But I'm only asking for those 5. The microprocessors, 16-bit, etc. So here you can sort it based on who the manufacturer is. Texas Instruments is one of my favorite microchip manufacturers. Tend to produce some pretty high quality stuff. Also calculators. But I mean, you can look at the different mounting styles. Mounting styles is oftentimes related to, okay, so now you have this chip. How do you access each of the pins on it? Here, this chip right here. I don't know if you can quite see that, but what you would have for this chip here is, in order to access each of the pins, this would be probably thermally pasted using some kind of a conductive material, or soldered even onto a printed circuit board, and each one of these pins would connect to a different input that would go to the device. They would all be routed through that printed circuit board. So it's just how you communicate with a chip. Now, most of these processors do require some. I mean, this is the kind of stuff that gets used in like cell phones and people who have professional equipment to mount these to a circuit board. We don't quite have that, at least not yet. It takes a fairly sizable facility to be able to to put one of these in place, because it has to be something that has certain ventilation requirements and certain cleanliness requirements, and it does have some waste product associated with it, but it's one of the reasons why I can't have the good things I want in life. It's because apparently we have to have healthy environments to teach classes in. Oops. But this is the kind of stuff that you'll see when you're looking at processors. Now these here, I'm not sure what the mounting type here is, but you can go down here. It always should have a data sheet. Again, the data sheet doesn't come from Mouser. It comes straight from the manufacturer. So here, if you want to read through this, it'll give you absolutely everything you need to know about this processor. It'll tell you that it can run up to 220 megahertz. This one can run up to 180 megahertz. It has on-chip memory. A lot of processors now will have built-in memory in the chip. Why? Because that's used for RAM. So here, this has 512 kilobytes flash program memory, and it's got 200 kilobytes of total SRAM. So I mean, this isn't something that you're probably going to be running Minecraft on. And we'll say that in jest. By the way, the cost of this is only about $8. So this one's it's not too bad, but it's also not all that great. You can have 8 GPIOs. This could be anything that would be connected to a button or connected to a switch. so that you can have direct control over sending signals to this, so it's not just serial connections or I2C connections. It does have a built-in 12-bit ADC with 12 input channels. So that's pretty awesome that it can read analog signals as well. And something like this would probably be used for there. Has nice timers, etc., etc. You keep reading on through here. Oh my goodness gracious, this is 171 pages long.
That's easy. The one I just looked at was 407.
Yeah. So yeah, the manufacturers put out a lot of documentation on these. And if you were to work extensively with one of these components, you would probably have to read that, or at least skim through most of it, understand what the content is. But there's a plethora of information available on every one of these products, and it goes down to how to mount it, how to program it, which pins have to be powered to cause what to happen, what performance limits are, what testing evaluation of these products is determined. It's just an extensive, overwhelming review of every single product. So, yeah. And then you can buy this thing and get its 171 page or 400 and some page document for less than $10. You want to know about any specific model, this is a good way to do it. So I'm going to jump into 32-bit microcontrollers. 32-bit microcontrollers, I believe, are as powerful as the Super Nintendo. Which is kind of awesome. Let's grab this one.
So for the assignment, do we just choose whichever one we want?
Yep. As long as you can get the information that are on the board, I don't care which one you want.
What do you want for the short description?
Just why, what are the perks of buying this particular model? What can it do? I mean, at some point, if you read through the features, you could summarize the features if you really want. That may be a good way of doing that.
Can we just put the short description that they put? Just to give a short description of what it is.
That's fine. I'm not requiring you to copy down from here, but I still do really want you to spend some time digging through the data sheets. Okay? Because understanding data sheets is a big part